So process managers often get, they're one of the more confusing things that people have to deal with. But if you start with them understanding what they're for and how things work, they become very, very simple to understand. So the first thing I'm going to talk about is a writer. And a writer is sort of the base between what some people might call an aggregate or microservice or process manager. In event source systems, a writer accepts input, manages its internal state, and then writes an output into a stream. So that writer, that fundamental approach is how every single object, every single service that you're committing into an event source system is going to use as its foundation. That's the commit basis for any application. And I think what gets confused is because people don't understand that process managers and aggregates have the same sort of abstract base of being a writer, and they just have different rules and approaches to doing that. That's why they get confused as how a process manager is different from an aggregate. So that is what we're going to talk about here. So one of the core things is that all of the writers that we're using are sharing a common log, right? So that means that any internal state I need from a reader pulling out the history, I'm going to have situations where I have multiple writers that are all sharing that same common log. And that's going to mean that if I need to, let me jump back a little bit here. So what we're doing in this writer or this aggregate is we're managing an invariant. And if I can keep that invariant inside a single object, all I then need is that single aggregate to manage that invariant. I don't need anything else. One service, one invariant. If I have, if I have two aggregates on a shared log, then I can use the log to manage the invariance between them using the write-ahead pattern. So that write-ahead pattern between those two aggregates allows me to use the common event log that they share to use. I am about to, if I'm doing a balance transfer between two of them and they're in the same shared log, then I can write into the log, reserve amount. So I decrement the balance from the first one. Then I can write into the second one, apply transfer, right? And then that begins the apply. Then I can go back to the first one and do confirm. So now I've got a shared invariant between the two aggregates that doesn't need any marshalling or any coordination other than the one shared log. So that's number one. So either it's in a single aggregate and I'm okay, or I've just shared invariant between two aggregates that have a common log. I can use the write-ahead pattern to talk between those two aggregates. The problem comes when I have independent applications. Because in this case, there's no one guaranteed source of truth I can look at to know whether or not things have been applied between the two different services. So this now requires some tracking to deal with the state in the two systems. And that state in the two systems doesn't require that the two systems need to be event sourced, right? What I need now is I need some place to store that state that is going to allow me to recover from any power cuts, is going to have a single place to track the process, if you will, as we update the state in the two different things. So this is where the process manager comes in. And what people often get confused about is that we're going to have one process happening in a single aggregate in one of those systems. On the right, we're going to see a process happening in a different system. And then the process manager in the middle is an independent stream that is going to be writing the state changes that are happening across those two different aggregates. So, for example, if I'm doing the bank account balance transfer now, I'm going to start the process manager to begin that transaction. And then it is going to trigger the aggregate. The aggregate on the left is account 1, aggregate on the right is account 2. The process manager in the middle is going to trigger the first one to say reserve, and then the first one is going to commit that change into its stream. The process manager will then recognize the state changes happened in the first aggregate. It's going to update its own tracking on that, and then it will trigger the second aggregate to make a state change. So the key here is that the process manager is responding to both commands and events, whereas an aggregate will normally respond to just events. And let me dig into that a little bit. I had a slide earlier I want to go back to and talk about a little bit here. What's important with a writer is the writer is going to respond to external input. And we generally divide that input into both commands and events. And the rules are simple, that a command, can be rejected. An event cannot be rejected, cannot throw an error. But that doesn't mean that the writer has to respond to or commit something based upon the event. So it's completely fine to drive a change off of an event and not just off of a command. But what needs to happen is we need to separate that command or event from whether or not we make the decision to produce an output from the writer into the local stream, right? If we're talking about accounts again, we might get an account locked event that goes over to a different aggregate. That aggregate can't reject that account lock because that account lock event has already happened. But it doesn't need to respond to it. So what's going to happen here is that if I get an event that says account locked, that means I may or may not write an event of my own into the log. So a process manager is going to be handling both the events from each one of the related components, and then also commands from outside sources to either create itself or do something else. So the key about whether or not to use the process manager is about your state. So if I can manage my state in a single aggregate, that's what I'm going to do. No process manager. If I have two aggregates with a shared log in the same domain, then I'm going to use the write-ahead pattern generally for simple process management applications because it doesn't require any additional services. It allows me to survive any power cuts. So by writing my intent into each one of these services, I can resolve that. And then I'm going to recover just using the shared log. Any reading or any reporting that I need to do on that shared log, that can happen off of the shared log and doesn't need a dedicated process manager. If I do have independent applications, for example, I might be talking to an external gateway, I might be talking between two event source things, I might be operating on an enterprise service bus. Then to coordinate multiple independent applications, I'm going to create a dedicated process manager. And the main thing is the aggregates will normally deal with a thing, and a process manager deals with a process over time. But it uses the exact same core patterns and the exact same core functionality that you're going to have in your aggregate. It's going to respond to events, it's going to respond to commands, and it's going to log activity over time. The one other time that you might want to have a process manager is if your process is complicated enough or is important enough inside of your domain that you want to track it as an independent trackable entity. You may choose to use a dedicated process manager to bring all of that business logic together. One of the best examples of that is, Greg uses this in a bunch of his courses, selling snowplows. If I'm in Canada and I'm selling snowplows down into the United States, that snowplow needs to be purchased by a city. It needs to be driven down across the border. It's a very long-running process. And unlike a transaction that I can roll back with a Saga, which is, in databases, I can't roll back the fact that I've driven the snowplow 100 miles. I've got a driver in a different country. I need to move forward in the process to recover that, right? So having a process manager which allows a dedicated tracking and a dedicated response to different things that happen is what allows us to use that inside of our domain to track the process and decisions of the business. I can see a question here. What is the write-ahead pattern? The write-ahead pattern means that if I have two different streams, here that I am coordinating, let's see. What I do is in each aggregate, I write my intended action before I do it. So I am reserving funds. I am applying, the reserved funds. I'm committing the reservation. The point is, by writing down what we intend to do, at any point when we restart, we can check to see if that intention has in fact been executed. And that's why we call it writing ahead. I'm going to write to the log ahead of doing the action my intent to complete the action. And if I do that for each step in my process, when I only have two aggregates that all share the same log, that log will contain every intent that I had all the way to completion. And therefore, I don't need a separate tracker because I can always recover my intention and my state for any objects that share the same log. It's only when we don't have a shared log that we actually need to have a dedicated stream to track the interaction between those two different operations. So that is my 15-minute spiel on process managers.
Thank you, Chris.